Everyone, good evening and welcome to my channel Aptitude Club. So this is the sixth session of remainder series, and today we are going to discuss binomial theorem. In the previous five sessions, we have taken different theorems based on remainders, different rules, concept of negative remainders, basic remainder theorem, Fermat's little theorem, Wilson's theorem, and Euler's theorem, rule of common factors. Everything we have discussed in a very systematic manner, and we have taken up extremely simple examples so that any one who is just beginning their CAT preparation, you will find it very easy and convenient to understand. The purpose of taking remainder section also I have explained, because numbers is such a vast area. Taking it at once might be difficult for a lot of candidates, and many people I have seen they skip, and they think numbers is some area that they cannot actually capitalize on. So a lot of people skip this area. So what I'll be doing is I'll divide the numbers portion into two, three important sections. Like remainders is one part. Similarly, I'll take another series on factor theory, and maybe another series on numbers algebra, divisibility, cyclicity. So if we do it in three parts and you focus on one part at once, you will find that okay, it's not as difficult as it looks. There are some areas which are very simple. As far as remainders is concerned, I'll repeat again, you do get questions, maybe not too many questions, but the questions that you do get from this section, if you understand remainders, you can solve them in less than a minute. That is the advantage of reading the remainder section. Okay, if you understand the concepts properly, you have practiced good number of questions, this is one area where you can guarantee that okay, if a question comes, remainders too I can handle very easily. So because this is the beginning step of your preparation, if you do it now, you don't have the pressure to read remainders in detail towards the end. ठीक है, जो लोग मे बी और 4 महीने बाद स्टार्ट करेंगे, they won't have this liberty that you guys will have who are starting their preparation now. And just watch the series end to end. I assure you that you will get to know what remainders is all about, and any question you will be able to answer on this. Okay, so today we'll be taking binomial theorem, especially the application of binomial theorem on the context of remainders. Binomial theorem is a portion of algebra, and binomial theorem से specifically अलग questions आते हैं. But how is this binomial theorem used in case of remainders? That is what we will go discuss in this section. So if you are new to the channel and you will watch, I'll request all of you to watch the entire video. And if you watch till the end and you like the content of this channel, do like and subscribe and share it with your friends also. I am trying to share as much insights as possible on my take of the quantitative aptitude section for CAT and other management interest tests. How do I look at the section and the tips and tricks and the way I prepared every chapter, and it helped me. I have scored 99 percentile multiple times. So I know what are the challenges and where can things go wrong. So that is what I try and share in my videos. Okay, so that you don't repeat the mistakes that maybe I have seen a lot of candidates repeat, and the things that I learned that can help you get to a good score quickly. That is how I'll try and explain in my videos, so that you get to understand the chapters very precisely and then solve the right questions which will help you reach there. Okay, so welcome once again to my channel, and let's begin with today's session, binomial theorem. So at first, let us see what binomial theorem is all about, then we'll go to understand how it is applied. So binomial theorem essentially is an expansion theorem. All right, so suppose, let me first write the expansion of the theorem, a plus b to the power n. Now in schools we have read a plus b whole square, a plus b whole cube, maybe some people have read a plus b to the power 4. But a plus b to the power n, in general any power, how do I expand? So a plus b to the power n, I can write it as nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b to the power 1 plus nc2 a to the power n minus 2 b to the power 2, and this goes on like this, ncn minus 1 a to the power 1 b to the power n minus 1 plus ncn a to the power 0 b to the power n. This is where the theorem ends. A lot of people get intimidated looking at these terms. At once it will look like ये क्या है, इतना difficult दिखता है. But you don't have to, first thing I'll clear out, you don't have to remember anything. You don't have to remember the theorem at all. तो इसको स्टेप वाइज समझते हैं. फर्स्ट थिंग इज व्हाट इज द टोटल नंबर ऑफ टर्म्स. पहले इसमें नंबर ऑफ टर्म्स देख लेते हैं. हाउ मेनी टर्म्स आर देयर इन द बाइनोमियल एक्सपेंशन. So starting from NC0, NC1, NC2, NC3, NC4 till NCn, so 0 till n. So I'll have total n plus 1 terms. From 1 till n it is n terms. From 0 till n it is n plus 1 terms. So this is total number of terms. Then you see with the first term, every power is given to a and b has nothing. A to the power n and b has 0. Then gradually once you try and go to the subsequent terms, the power of a keeps on reducing by 1 and power of b keeps on increasing by 1. Then if you go like this and you reach the last term, by the time you reach the last term, you give everything to b and nothing to a. The power of a last तक पहुंचते it became 0 and power of b it became n. So this is what the simple expansion is, and you just write the binomial coefficients. यहाँ पे जो nc0, nc1, nc2 till ncn binomial coefficients हो गया ये. So expansion is kind of simple. तुम nc0 से ncn तक लिख लो, and then first term you give everything to a and nothing to b. Gradually keep on reducing the power of a by 1 and increase the power of b by 1. By the time you reach the last term, a has nothing and b has everything. So we don't have to actually remember this. Just understand this. एग्जाम में दे विल नेवर आस्क यू टू राइट द एक्सपेंशन ऑफ बाइनोमियल थ्योरम, या ये एक्सपेंशन लिख के कुछ वैसा हासिल नहीं होगा. व्हाट यू अंडरस्टैंड फ्रॉम द थ्योरम, दैट इज व्हाट मैटर्स. So number of terms, and these are binomial coefficients. Now maybe a few of you would be not familiar with these binomial coefficients. So for them, let me write this, that this nc0 या nc1 या ncn. So in general ncr, I can expand it as n factorial by r factorial into n minus r factorial. This is the expansion of ncr. N factorial by r factorial into n minus r factorial. So for quicker calculations, you can remember it in this way: nc0 is equal to ncn is equal to 1. nc1 is equal to ncn minus 1 is equal to n. nc2 is equal to ncn minus 2 is equal to n into n minus 1 by 2. For your sake, let me calculate कोई एक constant तो तुम्हें समझ आ जाएगा. Suppose I'll calculate 8c3. So it is 8 factorial by 3 factorial into 8 minus 3 factorial. So it becomes 8 factorial by 3 factorial into 5 factorial. So I'll get 6 into, इसको अगर open करके solve करोगे, 6 into 7 into 8 by 6, तो 7 into 8 I get 56. This is how you calculate the value of NCR. This is what the theorem is. I'll take a separate session on binomial theorem in detail. Binomial theorem है क्या and इसको algebra के point of view से कैसे सोचेंगे. But today's session is focusing on binomial theorem from the angle of Reminders. How is this getting used in the context of Reminders? We'll try and understand that here. This is the whole theorem, especially the expansion. I hope all of you understood what the expansion is. Now just think about it. Let me write a few expansion binomial के point of view से, तो थोड़ा idea आ जाएगा कि है क्या expansion. Just for understanding sake, suppose मैं a plus b whole square लिखता हूँ. So I'll write it as 2c0 a to the power 2 b to the power 0 plus 2c1 a to the power 1 b to the power 1 plus 2c2 a to the power 0 b to the power 2. Similarly, a plus b whole cube, when I write, it is 3c0. I'll give everything to a and nothing to b. Then 3c1 a square b to the power 1 plus 3c2 a cube b to the power 2, sorry, a to the power 1 b to the power 2. a एक reduce हो जाएगा, and then 3c3 a to the power 0 b to the power 3. Same logic में you can write a plus b to the power 4 also. 4c0 a to the power 4 b to the power 0 plus 4c1 a to the power 3 b to the power 1 plus 4c2 a to the power 2 b to the power 2 plus 4c3 a to the power 1 b to the power 3 plus 4c4 a to the power 0 b to the power 4. ठीक है, इसमें बस फिर वैल्यूज तुम्हें सब सॉल्व करके निकालना है। ये 2c0 is 1, 2c1 is 2, 2c2 is 1, 3c0 is 1, 3c1 is 3, 3c2 is again 3, and 3c3 is 1, 4c0 is 1, 4c1 is 4, 4c2 is 6, 4c3 is 4, and 4c4 is again 1. ऐसा करके सॉल्व कर सकते हैं। Now one important observation, look at each term. पहले a plus b whole square में 3 terms आए, and in every term sum of powers of a and b is 2. पहले यहाँ पे 2 plus 0 is 2, then 1 plus 1 is 2, and then 0 plus 2 is 2. 3 plus 0 is 3, 2 plus 1, 1 plus 2, 0 plus 3. So I can say in the expansion of a plus b to the power n, in any term, sum of powers of a and b is always n, or it is like n is getting distributed between a and b. तो जितने वेज में डिस्ट्रीब्यूट करोगे उतने टर्म्स है। तो ये ग्रेजुअली ये बाइनोमियल थ्योरम यहाँ से बिल्ड होता है, बट विल नॉट गेट टू दैट पार्ट। अपना जॉब फॉर दिस पर्टिकुलर सेशन इज टू जस्ट अंडरस्टैंड द एक्सपेंशन, बस। फिर क्वेश्चंस इसका कैसे आएगा, दैट्स अ डिफरेंट सेशन टू लाइक डिस्कस ऑन, बट टुडे सेशन विल फोकस अभी इसको लेके हम रिमाइंडर्स में कैसे अप्लाई करते हैं। नाउ जस्ट टू एक्सप्लेन यू इन अ वेरी सिंपल वे, मान लो मैं ऐसे ले रहा हूँ a plus b to the power n, and when I divide this expansion by a, what will happen? ये a plus b का expansion, let me write it here, nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b to the power 1, and this will go on till ncn minus 1 a to the power 1 b to the power n minus 1 until I reach the last term where a to the power 0 b to the power n, and I'll divide this entire thing by a. Now if you recall basic remainder theorem, we had this rule that remainder of a sum is equal to the sum of remainders. ये था अपना। So I can say if the expansion is a sum, every term in the expansion is divisible by a except the last term. Can I write this? I can conclude every term in the expansion is divisible by a except the last term. This implies my remainder is only the last term, या लास्ट टर्म अगर डिवाइजर से बड़ा हो जाता है तो यू डिवाइड अगेन, बट यू गेट द रिमाइंडर जस्ट बाय लुकिंग एट द लास्ट टर्म. यू डोंट हैव टू लुक एट द एंटायर एक्सपेंशन, बिकॉज एंटायर एक्सपेंशन में एवरी टर्म हैज गॉट अ ए, सो इट इज डिविजिबल बाय ए. ओनली द लास्ट टर्म डजंट हैव ए टू द पावर 0 हो गया, so that is the last term is not divisible, so our remainder will come only from the last term. Rest of the terms they don't matter, वहां से remainder 0 आता रहेगा. So this is how binomial is applied in the context of remainders. Every term in the expansion is divisible by a except the last term. ठीक है, for an example. ठीक है, नहीं तो इसको और एक ये कर लेते हैं, एक साथ क्वेश्चन करेंगे. सेम लॉजिक में अगर मैं a plus b to the power n, I'll divide it by a square. Then what happens? nc0 a to the power n b to the power 0 plus nc1 a to the power n minus 1 b to the power 1, so on ncn minus 2 a to the power 2 b to the power n minus 2 plus ncn minus 1 a to the power 1 b to the power n minus 1 plus ncn a to the power 0 b to the power n. This total expansion is divided by a square. अगर a square से अब डिवाइड कर रहा हूँ तो फिर क्या आएगा? I'm not saying these questions are necessarily like have to be solved using binomial, but once you know कि क्या क्या players है इस field में, then you can decide depending on the question what to use and what not to use, which will be the shortest thing to use in this case, and then accordingly will solve. तो अगर a square से divide हो रहा है, now देखो यहाँ पे क्या आ रहा है, every term is divisible by a square. If you want to like divide a term by a square and you want it to be divisible, so minimum power of a has to be a square. So till this point everything is divisible, and the remainder will be given by the last two terms, because last two terms ही divisible नहीं होगा. यहाँ पे there is only one a, so it is not divisible by a square, and यहाँ पे तो a है ही नहीं. So this implies, यहाँ पे मैं ये लिख सकता हूँ, every term is divisible by a square every term is divisible by a square except the last two terms. Except the last two terms. This implies the remainder will be given by the last two terms. The rest of the terms I don't have to worry about. Remainder is given by the last two terms. बस इतना ही है सिंपल कॉन्सेप्ट बाइनोमियल का, लास्ट टर्म या लास्ट टू टर्म्स, इसके आगे जाना ही नहीं. इसके आगे अगर कहीं जा रहे हैं तो वी कैन यूज अदर थ्योरम्स, यूलर टोशन मेथड है तो वी कैन यूज दैट. ओके, तो लेट अस सी इसका क्वेश्चंस कैसे आता है एंड हाउ कैन वी सॉल्व द क्वेश्चंस. आई होप ऑल ऑफ यू गॉट अ क्लैरिटी. दिस इज व्हाट द एक्सपेंशन इज एंड देन इफ यू डिवाइड द एक्सपेंशन बाय ए तो ओनली द लास्ट टर्म इज नॉट डिविजिबल, तो वहीं से रिमाइंडर आएगा. यहाँ पे ए स्क्वायर में डिवाइड करो तो लास्ट टू टर्म्स, सिमिलरली ए क्यूब तो लास्ट थ्री टर्म्स एंड सो ऑन. तो एक एग्जांपल देखते हैं. सपोज आई विल से फाइंड द रिमाइंडर when 25 to the power 78 is divided by 8. सपोज ऐसा दिया है. अभी तुम ये 25 to the power 78 का जब एक्सपेंशन करोगे, this 78c0, मैं अभी समझाने के लिए एक्सपेंशन लिख रहा हूँ, you don't have to write the expansion. 25 to the power 78, sorry, 25 to the power 78 को let us write it in this way, that is 25 I'll write it as 24 plus 1. Why did I split it as 24 plus 1? Because 24 will be divisible by 8. जहाँ पे 24 है तो 8 से divisible हो जाएगा. So it is like 78c0, 24 to the power 78, 1 to the power 0, plus 78c1, 24 to the power 77 and 1 to the power 1, and so on. This will continue. 78c77, 24 to the power 1, 1 to the power 77, and the last term is 78c78, 78c78, 24 to the power 0, 1 to the power 78. So यहाँ पे again you see that in every term I have a 24. All these terms will be divisible by 8. So the remainder will only come from the last term. And what is the last term? 78c78 is 1, 24 to the power 0 is 1, and 1 to the power 78 is 1. So my remainder is 1. This is the answer. This is how binomial theorem is used. तुम बोलोगे सर मैं इसको बेसिक रिमाइंडर थ्योरम में भी तो कर सकता हूँ. 25, 25, 25, every time 25 is divided by 8, remainder is 1, 1 multiplied 8 times. वैसे भी कर सकते हो. Meaning is same. जस्ट आई एम शोइंग यू अनदर वे ऑफ थिंकिंग अबाउट इट. मैं नहीं बोल रहा हूँ कि ऐसे एक्सपेंशन लिख के एग्जाम में करोगे, बिल्कुल नॉट नेसेसरी. व्हाट यू कैन डू इट इन द एग्जाम इज दिस. विल राइट इट एज 24 plus 1 to the power 78 divided by 8. So it just becomes 1 to the power 78 last term. So 1 only the last term. तो बेसिकली ये यूज कहाँ पे होता है, जब तुम डिवाइजर नीचे जो है उसका मल्टीपल में प्लस माइनस 1 गैप में हो रहा हो. जैसे 24 प्लस 1 है और मे बी 23 होगा तो 23 माइनस 1 है. अगर ये क्वेश्चन 26 होता देन बाइनोमियल यूज करके भी कोई फायदा नहीं होता, बिकॉज इट वुड हैव बीन 24 प्लस 2, तो फिर 2 to the power 78 आता, फिर उसको सॉल्व करो तो ज्यादा कुछ फायदा नहीं हुआ. तो बेकार इसको क्यों करें, यूलर टोशन मेथड में सॉल्व कर लेंगे. बट अगर मैं ऐसे इसको प्लस माइनस 1 में ब्रेक करके लिख सकता हूँ देन इट बिकम्स वेरी कन्वीनियंट फॉर मी टू सॉल्व. तो उसी को प्रिंसिपल लेके आई हैव टेकन अ फ्यू एग्जांपल्स. लेट अस सी दिस. फॉर एग्जांपल दिस वन, 19 to the power 105 divided by 18. So I'll write it as 18 plus 1 to the power 105 divided by 18. Now in the expansion, every term is divisible by 18 except the last term. This implies remainder is the last term. And what is the last term? 105, C 105, 18 to the power 0 into 1 to the power 105. The value is 1. देख रहे हो कितना इजीली सॉल्व हो सकता है। तुम इसको बेसिक रिमाइंडर थ्योरम में भी कर सकते हो, नो प्रॉब्लम। आई एम जस्ट शोइंग यू एन ऑल्टरनेट अप्रोच हाउ यू कैन थिंक अबाउट द सेम क्वेश्चन बट इन अ लिटिल डिफरेंट वे। और एक यहाँ पे देखते हैं 31 टू द पावर 27 डिवाइडेड बाय 32। तो 31 को मैं कैसे लिख लूंगा ना, 32 माइनस 1 डिवाइडेड बाय 27। तो ऑल टर्म्स आर डिविजिबल, तो रिमाइंडर क्या आएगा, लास्ट टर्म। तो लास्ट टर्म इज लाइक 27c 27, 32 टू द पावर 0 माइनस 1 टू द पावर 27। तो रिमाइंडर यहाँ पे आ जाता है -1। ये तो नेगेटिव रिमाइंडर हुआ, पॉजिटिव कैसे करेंगे ना, -1 प्लस द डिवाइजर 32, hence you get 31 is the positive remainder. So going back to the principle, to make a negative remainder positive, keep adding the divisor until it has become positive. तो -1 आया, तो -1 नेगेटिव रिमाइंडर है, पॉजिटिव कैसे करोगे ना, ऐड द डिवाइजर 32। ये क्वेश्चन नंबर 2 हो गया तुम्हारा, सॉरी। सेम लॉजिक में क्वेश्चन नंबर 3, 84 टू द पावर 54 डिवाइडेड बाय 144। This is a little tricky. 84 to the power 54 divided by 144. The moment you look at 144, this is 12 square. Now 84 is divisible by 12, ठीक है। बट अगर डिनोमिनेटर या तुम्हारा डिवाइजर में 12 स्क्वायर है, इफ यू वांट अ नंबर टू बी डिविजिबल बाय 12 स्क्वायर, तो तुम्हें 2 84 चाहिए। यू नीड 2 84 बिकॉज तुम 84 का 54 में इसको अगर 144 से डिवाइड कर रहे हो, आई कैन से all terms are divisible by 144 except the last two terms. Why? क्योंकि लास्ट टर्म में तो 84 है नहीं, वो तो रिमाइंडर आएगा ही आएगा, क्योंकि उसमें 12 से डिविजिबल नहीं होगा। लास्ट बट वन टर्म, उसमें एक 84 है। अब एक 84 12 स्क्वायर से तो डिवाइड नहीं हो सकता, तो 2 84 रहेगा तो डिवाइड हो जाएगा, क्योंकि 84 इंटू 84 डिवाइडेड बाय 144 तुम ये कर सकते हो, 12 7 जा एंड अगेन 12 7 जा, तो ये डिविजिबल हो रहा है। So my remainder is basically the last two terms. So what are the last two terms? Now 54c 53, 84 to the power 1, सॉरी इसको मैं 84 कर दिया, 84 यहाँ पे तो रिमाइंडर 0 हो जाएगा, माय मिस्टेक, दिस शुड हैव बीन 85, लेट्स मेक इट 85, क्योंकि 84 तो डिविजिबल हो ही जाएगा, लेट्स मेक इट 85। 84 मैंने गलती से लिख लिया, कोई आई होप यू गॉट द पॉइंट, इसको 85 में लिख लेंगे। 85 को यू ब्रेक इट एज 84 प्लस 1 टू द पावर 54। सो जब एक्सपैंड करोगे, एवरी टर्म विल बी डिविजिबल बाय 84 एक्सेप्ट जो डिविजिबल बाय 12 स्क्वायर एक्सेप्ट द लास्ट टू टर्म्स, क्योंकि लास्ट टू टर्म्स में 84 स्क्वायर नहीं रहेगा। तुम्हें अगर 12 स्क्वायर से डिवाइड करना है, 2 84 चाहिए, तो ऑल द टर्म्स विल हैव 84 स्क्वायर मिनिमम एक्सेप्ट द लास्ट टू टर्म्स। तो ये 1 टू द पावर 53 हो गया, एंड देन दिस इज 54c 54, 84 to the power 0, 1 to the power 54. So this value is 1 and this value is basically 54 into 84 plus 1. Now 54 into 84 अगर करोगे, 54 into 4 is 216, 6 carry 21, 54 into 4 करेंगे तो, and then 54 into 8 is 432, 21, 4, 53. So 4536 plus 1. So I get 4537. इसको फिर से तुम 144 में डिवाइड कर लो, समझ रहे हो क्यों? बिकॉज रिमाइंडर हैज टू बी लेसर देन द डिवाइजर, सो यू विल अगेन डिवाइड इट बाय 144। अगर प्रोसेस में तुम मल्टीप्लाई करते करते तुम्हारा बड़ा रिमाइंडर आ जाता है, तो फिर से डिवाइड करोगे, यू विल कीप डिवाइडिंग अंटिल इट हैज बिकम लेस देन द डिवाइजर। तो 4537 अपना आया, इसको 144 में अगर डिवाइड करोगे तो चेक कर लेना फिर कितना आएगा, जस्ट अ सेकेंड। तो यू गेट अराउंड 73, ये कैलकुलेट कर सकते हो, बट द लॉजिक समझ रहे हो, हाउ इज रिमाइंडर्स यूज्ड। मतलब ये जो बाइनोमियल थ्योरम जब रिमाइंडर्स के कॉन्टेक्स्ट में आएगा, पहले तो क्वेश्चन ये तो बहुत ही इजी था, इसको तुम बेसिक रिमाइंडर थ्योरम में भी कर सकते हो, बट द मोमेंट वी सी दिस, यहाँ पे दो चॉइस है, क्योंकि 144 इज अ कॉम्पोजिट नंबर, ईदर आई कुड गो द यूलर टोशन मेथड वे, और बिकॉज 85 को मैं 84 प्लस वन, मोस्टली जब प्लस वन माइनस वन में होगा तब बाइनोमियल के बारे में सोचेंगे, एल्स द पर्पज इज कि अगर प्लस माइनस वन में लाइक कन्वीनियंटली हो जाता है, एल्स आई गो टू यूलर थ्योरम. So once you know all the methods, you have a choice to decide which method can I go, and it will help me calculate the answer easily. Okay. So this was more or less the application of binomial theorem on the context of reminders. I hope all of you got an idea about this. Binomial theorem separately, algebra के point of view से I'll take a complete different session, जहाँ पे तुम देखोगे binomial theorem का specific questions क्या क्या होता है. ये तो remainder angle से हम पढ़े, but only specifically binomial theorem, what are the questions? I'll take a very separate session on that, so don't worry about that. So that was it from my end for this session. Hope all of you got some insights and understood the examples and the concept that we discussed in this session. Thank you all for watching the video. If you are new to my channel, do subscribe to the Aptitude Club channel for more CAT related content. Do like the video and share it with your friends, and we'll meet again in the next video. Till then, have a nice day everyone. Bye bye.